device, a milling machine 40 meters long. Like an oversized cheese grater, the precision cutting head slowly cuts back and forth across the surface of the wing, painstakingly shaving the aluminium until the panel shape matches the 3D contour map stored in the machine's computer. The process takes up to 3 days. It eliminates 75% of the panel's weight while maintaining its strength. Then it's ready for the oven, one of the world's largest pressurized heat chambers, 42 meters long, almost 6 meters wide. Technician John Massey has cooked plenty of wings for smaller Airbus planes, like the A380.
It's a challenge to see it go from the size of the 320 to the size of the 380. It's a huge, huge jump.
The A380 wings are 50% larger than A320 wings. That means a 50% greater chance of error in this critical process. Baking requires careful setup. First, Massey and others place the segment in a special metallic form. Then they vacuum seal the entire assembly with a massive piece of plastic shrink wrap to protect the metal from contamination. Inside, the heat must be uniform across the entire panel, 150 degrees centigrade, with no room for error.
We try to avoid any changes in the vacuum or the temperature, so the temperature must remain constant right throughout the process. It must maintain within 3 degrees, otherwise the run is invalidated.
After 24 hours, the panel is ready. Specially equipped vehicles rise up and move into place in front of the oven. All eyes are on the plastic protecting the wing panel. If it breaks, the aluminium wing piece is compromised. A disaster. The entire wing panel would be worthless.
If the bag bursts, it means starting the job again from scratch.
Anxiously, they scan the surface for any breach. At last, the wing is cool enough to touch. And good news, the bag appears to be intact. Finally, the wing segment arrives in its docking bay. Here, the technicians first remove the plastic and cloth wrap. Now begins the tedious search for flaws. John's boss, Gareth Williams, arrives to inspect the piece. He retrieves small metal rods that were baked onto the top of the wing panel. Each of these cylinders tells an important story about future safety.
These are test pieces which are made of the same material as the wing panel, and we use them to confirm that the heat process that this part's just gone through is correct and it's to the right specification.
When this testing phase is complete, Gareth and John get the okay to move the wing to its next destination. The nearby wing assembly plant, an enormous brand new factory located just up the road. It's one of Britain's largest industrial buildings built in this century. It's nearly 85,000 square meters in area, equal to 12 full-size football pitches. This is where the builders attach the aluminium skin panels to the wing skeleton. George Lee guides his team through the tricky assembly process. Today they're preparing to lift and place one of the largest of the 20 aluminium panels, 34 meters long and weighing in at more than 1 ton.
Size is a great challenge because everything requires some form of overhead lifting. Nothing can be lifted manually, so virtually everything requires overhead craneage movement, and therefore the management of the craneage system is very, very important.
The panel hangs like a huge guillotine, suspended over the factory floor. But that's not all that's hanging over the assembly team's head. Time is running out. Along the edges of the partially constructed wing, builders have applied a sealant that will help to ensure the integrity of the fuel tanks. The sealant dries quickly within hours. The team must fit the wing panel into place before the sealant dries, or the wing could be defective. This time they're cutting it close.
The only concern I've got is the time factor.
If they don't succeed, the team will have to scour the sealant off the aluminium surface and start the whole process again. Finally, the panel settles into place, one down 9 to go.
It can be stressful, yeah, it can be stressful. At this certain times, it's an enjoyable job, because when it actually all works and goes together, it's quite enjoyable. You've made it an achievement.
Now it's time to glue and bolt together the pieces, like building the world's biggest model airplane wing. This part of the process remains a carefully guarded trade secret. The company wants our cameras off.
No cameras.
The secret assembly process inside the jig will take nearly 4 weeks to complete, but it takes more than a wing to make a plane. All across Europe, more factories are coming online, pumping out body parts of this giant Franken plane. But not everyone is happy to see this kind of progress. Some locals in Germany are up in arms over Airbus's ambitious plans. This is the newest Airbus factory in Hamburg, a megastructure big enough to house 4 A380s side by side. Airbus has been building airplane fuselages in Germany for more than 30 years. But with the announcement of the A380, the company needed to massively expand the site and send finished planes here to get tricked out on the inside and painted on the outside. No matter what the customer wants their plane to be, a 550-seat cattle car, a high-class hotel in the sky, or even a heavy-duty freighter, this is where the seats, the carpets, the stairs, and yes, even the bar and the waterfall will all be installed. The expansion plan called for 3 new buildings and a longer runway to accommodate the massive plane, but there was a problem. Airbus's main factory here sits alongside Germany's Elbe River, smack in the middle of Europe's largest tidal wetlands.
It's a very special area because we have there the influence of water from the country and tidal water from the sea. So we have a mixture of sweet water and salt water.
This fragile ecosystem is home to 70 species of migratory birds. Now 71 if you count the Airbus A380. Airbus wanted to fill in 140 hectares of pristine wetland, and local activists cried foul. A pitched battle in the courts and demonstrations in the streets delayed construction of the factories for over 2 years. But eventually, local and national politicians who wanted to bring business to the community intervened. The factories went up. One got busy building fuselage segments, but the other 2 stand nearly empty. More lawsuits still block the Hamburg facility from taking delivery of all of the planes it's meant to finish. Unless the company wins in court, it may have spent a few $100 million building a factory of little use. The problem lies with the runway. Airbus needs a longer runway to accommodate a heavy-duty cargo version of the A380.
We need the runway extension in Hamburg for the pilot to test the performance of the aircraft. And he only can test this when he has an aircraft with a weight which is approximately the weight you normally have in cruise altitude and a normal scheduled flight.
That plan to lengthen Hamburg's existing runway has met with considerable resistance from locals. Their concern: extending the runway will bring the tarmac to within just 450 meters of village orchards, and uncomfortably close to a Lutheran church that houses a priceless organ built in 1688. A delicate instrument that could be damaged by ground vibrations and wake vortices, turbulent bands of air similar to miniature tornadoes.
We have very precise information on is the generation of these wake vortices, so small, let's say, tornadoes, wind generated by every aircraft, more or less, which can affect buildings and also persons close to the runway or close to the flight path. And we have predictions that we should expect occasionally winds up to Beaufort 12, which is about 130 kilometers per hour in the core, and these tornadoes will hit the church tower and the roof construction.
Villagers may have reason to be concerned, For years, they've tolerated another big plane in Airbus's fleet, the Beluga, a custom